I just finished the last piece of this iteration of wanix, and I wanted to document it. So to set this up, though, let's kind of look at what we're looking at by just viewing source for this page. So we set up a wanix namespace, and this namespace has is basically the Alpine root file system is mounted at root. I also mount in the hidden wanix namespace just to help identify this as this namespace and not like a Linux root. And then this is kind of a special bind because we're binding into the sort of hidden or system namespace. And I'm using this as a pattern to sort of load effectively a driver. So v86 is now a separate, binary, and it's not part of the core because it also has these other resources as well. So we kind of bundle that up here. So we mount that in to this location, and so now it's like, okay, here's the v86 VM driver, which is the default. So then we set up a VM here, and there's a bunch of defaults behind the scenes because it's sort of in development, but basically it's starting a VM based on this namespace. So it's actually booting off of this namespace in Linux, and it starts the bin init that's in here. So we also have this new attribute called export, and if this is set, then the init script is going to run host export, which is kind of like exportfs in Plan 9, and then it runs that against the TTY S0 serial device, and so then that's basically saying, hey, this is basically the equivalent of guest tools, having some kind of guest service running in your VM. And I wanted to have that really integrated here. And that's kind of what I got working here just now. So we set up the export, we say allocator terminal, and then auto start. And then we also set up a terminal pointing to that VM. We know it's going to be ID1. And it's already a line discipline terminal, so we run this as a raw terminal. So anyway, that gets us this page, which loads pretty fast. So it's starting the VM, so it's basically booting Linux. Now it's in Linux, and so the init script started, and then in the background ran the host export, which first signals over the serial port before running the 9P server, so that the other side can then say, okay, when I get that first byte, that's when I'm going to try and mount the guest so that it can get that timing right. And so because of that, it's really fast. So like, not only is the Linux booting pretty fast for Linux, but then once the actual init script inside runs, it's pretty much immediate. And then to actually see this work, I guess, is to see. We'll do this here. So where it mounts the guest is under guest, under the VM resource. And even though the guest system is Linux, the host export will create a kind of an adapter to export wanix-like file system, mostly task, which is how you run processes, and expose it so that when you use that file system, it'll shell out and run a process on whatever Linux system. And so that's kind of the point of this whole thing, is so that we can get this. And so if we list new, we see the different task drivers, and that's how we can tell that this is running inside the VM, because native is basically anything that's not WASM. And so now basically the point of this is to say, when you start up a workbench instance, which is VS Code, you have to tell it how it can start processes. How does it start a terminal? Because when you start a terminal in VS Code, it shells out and runs your shell. It starts a process, and so Workbench has to know how to do that. And so I ran into this issue where it's like, oh, but actually we want the shell for VS Code to be in the VM, and so how do you get that to happen? So now you can just say Workbench, use this task namespace, and it will start a process inside the VM over this guest service. Anyway, pretty cool. I'm super excited. This is just the tip of the iceberg of this stuff.